Okay, so not every tune-up is this fun. As you can see, not much room in this attic, but you get these once in a while, so you're just gonna have to deal with it. Entrance is over there, so a little bit of crawling around, try not to smash the flex. But as you can see, this is a horizontal, 80% efficient with air conditioning. This does a second floor, and first floor has a boiler. So this does second floor and air conditioning. So I'm gonna get into this, but I just wanna kind of show you what we're dealing with in here. A little bit tight quarters, but we're still gonna tear this thing apart, take a look, make sure it's all tuned up, ready to go. That's where we're at. Let's get into this. All right, I just got both the doors off. These just slide off. No screws or anything on this style. This fan, is you can see, is just a regular motor. Oh, look at that. That wet spot is oil from the motor. Maybe. What in the world? I have no idea what that was. All right, so take a look here. Kind of looks like oil. Yeah, it's oil. Greasy. So that motor's leaking oil. I don't know if you can see it. But that's going to become a problem. Those bearings are sealed bearings, and they should not be leaking. So eventually that motor's going to wear out. And you can see the two brown wires. There's no ECM module, so it's just a regular PSC motor, permanent split capacitor. So there's a capacitor right there. All right. We'll have to find out what size it is. We'll check capacitance on it, make sure that that's okay. We just pull the wires off and we'll check the capacitor with the meter. Just gonna look over some of the wiring, the control board, make sure we don't see any burn marks or loose wires. Make sure everything's plugged in. And then one thing I do every tune-up, every tune-up, I don't care how old it is I'm gonna check the heat exchanger. I got my camera here. I'm gonna take off the high limit, and I can stick my camera right through the hole of the high limit, because normally I like to go into the back of the unit, but I can't get back there. There's no ductwork to get into or whatever, so I'm just gonna go right through there, and I should be able to get this. So I check that heat exchanger on every time I do a tune-up, which hopefully is every year, because we've had 1-year-old furnaces have holes, I mean gaping holes, where it just blew out. 1-year-old, just last year, had one. We had them 3 years old, 5 years old, with big holes or huge cracks. So I check them every time, because I'm not going to leave that house and have something happen to a customer. Right? I know a lot of people get upset with that. They think it's a scam that you're trying to sell them a furnace. But really, I've just had too many issues with cracks and holes. I'm going to check it every single time. So we'll be able to get in there. If you can see those divots, those round spots, you'll see a lot of times there'll be cracks right along the edge. Hopefully not on this one, but it does happen. So that's one spot I look. Looking at those little pop rivets back there, looking at any kind of bend, looking along these dark spots, that's the heat spots, looking for cracks. You never know what you're going to find, but you want to look all over the heat exchanger as much as you can. Multiple panels, so there'll be another panel up above it. And we're going to check all in there. If I can, I'll send the camera through the holes here and look down there. Look for excessive rust, corrosion, cracks in there. Anywhere I can. Old style hot surface igniter here. You can see it there. These are the real brittle kind. That right there. It's real brittle. They used to tell you not to touch them, kind of like a halogen bulb. They would say that oils on your fingers could burn them out. Don't know that that's true, but I just make it a habit not to touch them. And they're really brittle anyway, so you got to be really careful with them. I've broken quite a few just trying to look at them. But all we're going to do is I'm going to pull this plug. Pull this plug apart. If I can get it. Let's see here. There we go. All right, and you're going to check the igniter side. I'm going to put your leads on those two posts and do an ohm reading. Now, every manufacturer has different ohm readings for different hot surface igniters. So you have to look it up. You can do a quick Google search. Come on. And look for that model. It says model. Look for that model, and there you might be able to find an ohm reading that it's supposed to be at room temperature. So if you just had this running and it's really hot, then your resistance is going to be higher. So you really want these to be at room temperature. And some are 15 ohms, some are 50, 55, some are 100, some are 150 ohms. So it really depends. You have to look it up and find out what ohm reading you're supposed to be at. Now, if you come up to one and it goes OL on you, open line or open limit or whatever you call it on your meter, if you get an OL and you don't get any kind of reading, then that igniter's bad. So my experience has been, I have never found one that's been out of range. I've found them where they're bad or they're working. I know some people will tell you, oh, they can be out of range. I've never seen that. I've checked hundreds, if not 1,000 of these things. Never seen one out of range. And some of that, you got to be careful. I think some of that's a scam. But I do test them. I check them. You know, maybe there's one day I'll find one that's out of range. So you just want to do your diligence. But it is a good test. You don't have to pull it out to see if it's bad. If you pull it out, if you just pull the plug and test it, you can see, is it good or is it bad? It's basically what you're going to find. If it's bad, it's not going to work. I just saw this. I don't like this. This wire's sitting right in the middle there. That's another reason we do tune-ups. We find weird stuff like that. That's to the that's to the flame sensor, which we're going to pull out and test. We're going to check that. Super easy. Man, you need to do this all the time to clean these flame sensors. So easy to clean these on most systems. I know some stupid carrier ones are hard, but you need to clean these. It's so easy, and it's horrible to have to come back to these just because you didn't clean the flame sensor when it only takes a minute. So I'll do these even if I'm, you know, just looking at somebody's furnace. If I pull it out, I'm going to brush it off because, again, this is a brass brush. so that we're not scratching it, we're not leaving residue. And we're just going to brush this thing off. I don't know if I can hold this and show you guys how I do it, but just brush that off real good, put it back in, and it should be good. You can also test these. Once you put it back, and you put alligator clip on this side, and you pull this apart. All right, you can put alligator clip here to hold it on there. You can put your lead right in there. Go through your meter. You're going to check microamps. Check microamps, or sorry. Let me think. Yeah, you check microamps because amperage, you're reading through it. You're reading in line. You should get between 2 and 4 or 6 microamps. And if it, on most furnaces that I've worked with, if they drop much under 2 microamps, then it shuts the flame off. Boilers might be different. High efficiency boilers, they can be up around 20 microamps or more. So it just depends. Most furnaces are above 2. All right. We're going to check the exhaust fan, make sure that's working good. Checking the piping. Make sure everything is clear. Make sure it's plugged in good. Not getting a lot of corrosion. We're going to go through the sequence of operation. I'm going to check, when the thermostat calls on this. I forgot what system I'm using here. What is this guy? Pain. It's a pain. I'm going to check now with the carrier brands. If you have the thermostat calling for heat and you turn the power on, then it goes into a 1 minute or a minute and a half fan cycle where the fan just runs. And then after that, it starts the order of operation. And that is then thermostat's calling. So it sends power to the exhaust fan, the inducer. That inducer is going to run. It's going to pull on the pressure switch. So we got inducer, pressure switch. And the pressure switch makes, then the igniter is going to come on. When the igniter comes on, it's going to be on for a little bit. This one's a hot surface, of course, so you're going to see it glow orange. When that's been on for a little bit, then the gas valve will open. The gas valve opens, it ignites. If that flame ignites, it's going to run from this first burner by the igniter. It's going to travel across to the last one by the flame sensor. And that flame sensor will sense a flame. If it doesn't, within a few seconds, it's going to shut the gas valve off. That flame rod has to prove that there's a flame. So when these get dirty and they can't feel the flame anymore, it can't complete the circuit through the flame rod, then it'll shut the circuit down. But if it goes to flame rod and it proves the flame, then it'll continue with its operation. The flame stays on and the fan will come on in about a minute and a half. Most new furnaces are a timed delay fan, about a minute to a minute and a half, I think. Some of the older furnaces had an actual fan limit where it had a dial. It was a big unit that kind of slid in there and it had a dial in it. It was a bimetallic strip that was spiraled around. And as that would heat up, the bimetallic strip would spin. It would spin the dial till it got to a certain temperature, and that would make the switch for the fan to come on. And once the fan cooled down the heat exchanger enough, the dial would turn back, and it would shut the fan off, but the flame could still go. And so you kind of have this fan turning on and off depending on your system. So, all right. Well, we're going to check the heat exchanger. I'll let you know if I find anything. Clean this up. We'll check the igniter. I'm going to check the capacitor, see what size it is, how many microfarads. Make sure it's within 10%. Motors need to run. Motors need those capacitors to be within 10% of its rating to run properly. The listing on the capacitor that says, you know, plus or minus 5 or 6% is a guarantee from the manufacturer that when you buy it, it will be within 5 or 6% of what they listed at. It has nothing to do with what that motor wants or what they've designed these motors to do. So everything we work with needs to be, the capacitor needs to be within 10% of the rating on the capacitor. Otherwise, the motor might run wrong. You might get weird fan speeds or whatever. You can burn the motors up too if it's way off. Those motors will burn out. Okay, I think that's about all. We'll get into this and see how it's going. I'm gonna check the heat exchanger. Okay, so I actually took the panel off. There's just 2 screws. I hold that. It's easier to get to the capacitor that was tight on there. Took this off. It's a 7.5 microfarad. Again, M. That is not a U. It's not a U. That's a Greek letter M. You try to use that for microfarads. I know people call it UF because it looks like an English U, but old school Greek M. So 7.5 microfarad. We got this on the capacitance, either the symbol for capacitance on yours, on your voltmeter, and then or MFD microfarad. Okay, so this has to be within 10%, and we're just gonna go one to the other. Hold it for a second. Let it adjust. There you go. All right, 6.68. Now, so 10%, we're 7.5. Then we can be 3/4. We can be 0.75 off. So we can go up to 8.25, or we can go down to 6.75. This is super close. At this point, your meter can be slightly off. I mean, this is so close. Normally they're farther off than this. So at this point, I'm telling the customer, hey, it is technically out of range. If you want, I'll replace it. If not, we can check it again in the spring. We'll be back here in the spring to see how it's doing for the air conditioning tune-up. So, and if it's gone farther out, then, you know, we can replace it at that point. So technically it's out of that 10% range. At the very least, I'm bringing it up to the customer, let them make the decision. Easy part to replace, one of the cheaper parts to replace. So, hey, why not? At least you know it's not going to fail if you replace it. If you don't, normally they don't just fail. Unless you have like overheating. If for some reason it's overheating or drawing too many amps through the motor or something. A lot of times they fail because they overheat, like either by amperage or by actual heat. We are up in an attic. It's up in an attic, so we can be at 130 degrees up here sometimes. Maybe even more depending on how hot it is outside. But they do fail, so we just got to keep that in mind. So I'm just going to bring it up to the customer, see what they want to do. It'll be up to them. All right, and I did check the heat exchanger. I saw some corrosion, but not any cracks. So this one's good to go that way. We checked, we cleaned the flame sensor, put that back in. The ohm reading on this is good. It's not bad. It hasn't cracked or anything. So I think that one's good to go. We're gonna fire it up. We'll check temperatures. I got my probes, the new Fieldpiece ones. These are the JL3 RH with updates so that they do go up to 250 degrees now instead of 140. If you have some that's about 6 months to a year old, you might want to check for the updates, because they only used to go up to 140 degrees. Now they go up to 250. And it's pretty simple to do the upgrades on those. If you want a good video on that, Quality HVAC has a good video on how to do the updates on it. It's pretty simple. Otherwise, if you just go to the Fieldpiece app and go to the settings, I think it'll show you, and then it kind of walks you through it. It's not real difficult. But yeah, I'll put those in. We'll check temperature rise and make sure it's within the range. Temperature rise should be on a label, and it should be up in here. 40 to 70 degrees is the temperature rise. So that's what we're looking at. So you should be between 40 and 70 degrees from the supply to the return. This one has one return up there. So we're going to check in the return, we're going to check in the supply. Should have a 40 to 70 degree difference. Okay. We'll put this back together and fire it up. Alright, I wanted to show you this because I just found this. And this is why we check, and I grab these wires and pull on them. Because I just grabbed this one. I wasn't even behind there, tightened down. It was just sitting up against there. So as long as it was making contact, it would work, but that wasn't even in there. So there's a good possibility that could have vibrated loose and he'd get no heat. So I always give it a tug on all of these just to make sure that they're all tight. Nothing's coming loose. Funny thing is, I think I was the last one here. Oh yeah, furnace tune-up last year. I don't know about AC tune-up. I'd have to take a look at that. Maybe I can blame the guy that was here for the AC. Alright. But, yep, make sure those wires are all tight underneath there. Okay. Hold on each one of them. Alright. Red, 24 volt power. Green, fan. Yellow, or this manufacturer didn't have a yellow, so we're using blue. But Y is for yellow. That's air conditioning. W is white for heat. And we have a common. It is not a Wi-Fi thermostat, does not need a common. It's not a power stealing thermostat, so it has batteries. So that common is for the 2-wire to the outdoor condenser. So for air conditioning. Alright. Green, red, yellow, white, common. Fan, power, AC, heat. Okay, we're gonna start this thing up in a minute and watch it fire. I just put the door back on and the fan started up right away. So like I said, with Carrier brands, that's Carrier, Payne, Bryant, the thermostat is calling for heat and I turn the power on. So they go into a minute or a minute and a half. Fan only runs through just to make sure that the heat exchanger is cool, then it starts it up. And then I'll go through the sequence operation. And we'll check the flame. I was going to show you this one, so I can do this. our alligator clip set up. I'll check microamps on the flame sensor, see what the reading is. So pull this off. This is awesome. There we go. Got my alligator clip on there. And take this one and just stick it in. So it stays, got good contact. And set this on microamps. Once that flame comes on, we should see some microamps. We got exhaust fan, pressure switch, but listen carefully, you can hear it. I got hot surface igniters going. So with the gas valve. All the way across pretty quick. Staying on. And we have, oh yeah, that's a good one. Yeah, almost 6. So we got good flame sense. Now, if I were to just pull this off, it would act like the flame sensor is dirty where there's no flame. So it would make the circuit and they will shut down. So I'm going to let this run, get into the fan at least. Because the next thing, the fan will turn on. Check some temperatures. I got my Fieldpiece probes and check the temperature and do it at the same time. Pretty good. Not too bad. Serial number. With the model and serial number, the serial number tell you the date. On carrier brands, the first 2 numbers are the week number, the second 2 are the year. So I can't see it. I can't get down there. Oh, 0301. So 3rd week is early January, 3rd week of 2001 is when this unit was manufactured. So this one's 21 years old. Still pretty decent condition. That should probably get sealed up. Pretty good. That's all for this one. This unit is running pretty nice. A couple other things you could check is amp draw on this motor. These motors should never run more than they're labeled. This one's not labeled. So I'm not really sure what I'm about 1.75 amps, somewhere around there. If it's running higher than the amp draw that it's rated at, then something's wrong with the motor. You could also check your incoming voltage, and we could do that here. See what the whole thing runs at. And yeah, watch out for the magnets on here. It's going to give you a goofy reading. It's a good lesson for you. Get this away from those magnets. Alright, so not too bad. 2.75, but if I get close to that magnet, you got to remember these clamp-on amp meters, they run on magnetism. The magnetic field around the wire is what it's measuring. And so if you get close to an electromagnet, any kind of magnet, it's going to throw that reading off. So try to stay away from the magnets so you get the best reading. Maybe if we went down onto here, away from any electronics, that's going to be your good reading right there. And it reads best right in the middle. That's where it's ideal. The wire right in the middle. So 3.3 amps, which is pretty good. If you want to know, it's 120 volts. So around here, a lot of times it's 124 volts. So 124 times 3.3, that'll give you how many watts. Volts times amps equals watts. So you can kind of tell how much power this is using to heat the house. I just thought I'd mention one more thing. So this is an 80% furnace. That means that the fuel that comes through is burning 80% of it's used to heat the house. 20% is going out your chimney. So 80% efficient. But then the other thing too is they have a couple of different styles of furnace. You can have an 80% sealed combustion. This one is not sealed. It's not a sealed combustion. Notice that the top door here has holes in it because it's got to draw air for combustion. Well, since this is open, it is not a sealed combustion furnace. You can have sealed combustion 80% furnaces. Most, I would say most, I think all high efficiency furnaces are sealed combustion. But you just want to watch that. Some of the older furnaces, most of them had a burner box. So like around this part, this would all be sealed up in a box with covers and everything. So it would be sealed combustion from there. You'd have an intake port in this box. The newer furnaces, they use this whole upper cabinet and seal the whole upper cabinet. So if you come to a furnace like that, where like a high efficiency, and there's not a box around here that's sealed, and you start seeing stuff like this where they didn't put a gasket in here, then what's supposed to be a sealed combustion is no longer sealed. So you want to watch out where this furnace is located. If it's located by a lot of flammables, especially if it's in a garage, then it has to be, I think code around here is 18 inches off the floor. You do have to be careful. Sealed combustion is there for a reason, a couple of reasons. One is flammables in the area. The other is just it protects the heat exchanger, so you're not pulling chemicals in that are going to get in and eat up the heat exchanger, especially in basements. If there's cleaning stuff or bleach from washers and dryers, you don't want to be pulling all that junk into the heat exchanger and corroding your heat exchanger. So they bring fresh air in from outside for combustion. Also, with sealed combustion, if you have a two-pipe system, you don't have to draw air from the house for combustion. You're bringing air in from outside, so you can pretty much seal up a furnace in a tiny little closet and not have to worry about it. It's going to function fine because it's drawing its own air in from outside. Okay, just a few more things I thought I'd share.